Today, we're learning confidence intervals, and I'm going to show you exactly what that number actually means, because most explanations get it completely wrong. Stick around, and at the end, I'll show you the one phrase that students write on the AP exam that costs them full credit, even when their math is perfect. You need to know this. Okay, so before we touch the formula, I want you to have this picture in your head. Here's the analogy that's going to carry us through the whole video. Imagine you're fishing in a huge lake, and you want to know what fraction of fish are bass. You can't check every single fish. The lake is massive. So you cast a net and pull up a sample. From that sample, you estimate the true proportion. A confidence interval is your net. It doesn't catch every fish. You're not claiming to know exactly, but you're pretty confident the truth is somewhere inside it. We're going to come back to this image. For every single piece of the formula, wider net, higher confidence, less precision. Tighter net, more precision, less confidence. That's the whole intuition. So, what exactly is a confidence interval? It's three pieces. So, we have the p-hat. This is your sample proportion. If you survey 200 students and 84 said they preferred music, p-hat is 84 divided by 200, or the true proportion of students who prefer music. It's your best single guess. Now, here's the margin of error. This is how far you're casting your net, how much uncertainty you're building into your estimate. Third one is the interval itself. P-hat plus or minus the margin of error, a whole range of values. The true proportion could plausibly be. Now, at the bottom, here's the formula. This is the one you need to memorize. P-hat plus or minus z star times the square root of p-hat times 1 minus p-hat, all divided by n. I know that looks like a lot, but we're going to break it apart right now. Let's go piece by piece. So p-hat, that's just what you got in your sample. Divide the count of successes by n. Simple. Z star, this is your critical value. It comes from the table, and it depends on your confidence level. For a 90% confidence interval, Z star is 1.645. For a 95% confidence interval, it's 1.96. Make sure you memorize that one. It's very important for the AP test. For 99%, it's 2.576. Now, higher confidence level means you need a wider net, so Z star is bigger. Now, we have standard error. This is how spread out your sample proportions would be if you kept taking samples. The key insight. Bigger n means smaller standard error, means a tighter interval. More fish in your net means a better estimate. Now, wait. Before you use these formulas on your AP exam, you have to check three very important conditions. Miss any one of them and you'll lose points, even if your calculation is perfect. Condition 1. Random. Your data must come from a random sample or randomized experiment. If someone just asked their friends, the math is meaningless. Your net was cast in the wrong spot. Number 2, large counts or the normal condition. You need n times p-hat to be at least 10, and n times 1 minus p-hat to be at least 10. This ensures the sampling distribution of p-hat is approximately normal, so z star is valid. Now, it's very important you must show the numbers and show work. Don't just write a check mark. Write n times p-hat equals 200 times 0.42, which equals 84, which is greater than or equal to 10. Show your work for every problem. Now, condition 3, the independence or 10% rule. Your sample size should be no more than 10% of the population. If you're surveying students at the school of 2,000 students, your sample of 200 is exactly 10%, and that's the cutoff. Usually this one's fine, but you still need to state it and prove it. Okay, let's try solving this. In a random sample of 200 students, 84 prefer studying with music. Construct a 95% confidence interval for the true proportion of students who perform music. So for step 1, we're going to state our parameter. We want to estimate P, the true proportion of all students who prefer music, and we're going to construct a 95% confidence interval. Step 2, conditions. The random condition. The problem says random sample, so we're good. Large counts. N times p hat is 200 times 0.42, which is equal to 84. That's at least 10, so that's normal. N times 1 minus p hat is 116, and that's also at least 10, so that's normal. Now the 10% rule. 200 students is almost certainly less than 10% of all students. All three conditions check out and make sense. Step 3. Calculate. P hat is 84 over 200, which equals 0.42. The standard error is the square root of 0.42 times 0.58 divided by 200, which comes out to be 0.0349. Z star for 95% is 1.96. So the margin of error is 1.96 times 0.0349, which is equal to 0.0684. Step 4. The interval. 0.42 plus or minus 0.0684 gives us 0.352 to 0.48. Now, how do we write the conclusion? I'm going to come back to that in a minute. Just trust me. This is the most important slide in the whole video. I've seen students do perfect math and lose full credit because of how they wrote the last sentence. This, the red box, is completely wrong. We are 95% confident that the true proportion is 0.42. That's describing the point estimate. You didn't even mention the interval. Now, this one's also wrong, and this is sneaky. There's a 95% probability that p is between 0.352 and 0.488. The word probability is wrong. P is a fixed number. It's either or isn't in your interval. You can't assign probability to a fixed value. The interval is what's random. Now, here's the right way. We are 95% confident that the true proportion of students who prefer music is between 0.352 and 0.488. What you need is confidence level, the word confident, not probability, and a description of the parameter and context, as well as the actual interval values. Let's do a harder one. A local newspaper claims 60% of residents support a new park. A researcher randomly surveys 400 residents and finds 228 residents who support it. Construct a 99% confidence interval and determine if the newspaper claim is plausible. P hat is 228 over 400, which is equal to 0.57. The conditions random, large count, 228 and 172 are both well over 10. So the 10% rule is also fine. Now, the standard error, square root of 0.57 times 0.43 over 400 equals approximately 0.0248. Z star for 99% is 2.576. The margin of error is 2.576 times 0.0248, which equals 0.0639. The interval is 0.57, or the parameter, plus or minus the margin of error, or 0.0639. And that gives us 0.506 to 0.634. Now, the verdict. Is 0.60 inside our interval? Yes, 0.06 is between 0.506 and 0.634. So the newspaper's claim is plausible. So we're going to say we fail to reject the null. Notice I'm not saying the newspaper is right. I'm saying their claim is consistent with our data. It falls inside our net. Okay, pause here, write out your work, and don't just read the problems. If you're not writing, you're not learning. Let's go through the answers. Question 1. P hat is 78 over 150, which equals 0.52. Standard error is the square root of 0.52 times 0.48 over 150, which is about 0.0408. Z star for 90% is 1.645. The margin of error is 0.0671, and the interval is from 0.453 to 0.587. The conclusion is we are 90% confident that the true proportion of voters who support candidate A is between 0.453 and 0.587. Question 2. P hat is 204 over 300, which is 0.68. Standard error is about 0.0269, and the Z star is 1.96. The margin of error is 0.0527, and our interval is from 0.627 to 0.733. Now, question 3. This one is sneaky. A lot of students see the interval 0.41 to 0.59. Notice the midpoint is about 0.5 and think, well, there's more above 0.50 than below, so the majority is supported. Wrong. The interval includes 0.50. That means 0.50 is a plausible value for the true proportion. We cannot conclude that more than half exercise daily. We cannot rule out exactly 50%. If you got question 3, you actually understand confidence intervals, not just a formula. Okay, I told you at the start, I'll show you the thing that costs students points. Here it is, 95% confident. That does not mean that there's a 95% chance that the true values in this specific interval. It means if we repeated this process many times, taking a new sample, building a new interval each time, about 95% of those intervals would capture the true parameter. The confidence is in the method, not in this one specific interval. This distinction is worth points on the AP free response questions. The AP graders are looking for it. Now, at the bottom, screenshot the cheat sheet, Z-star values, large counts conditions, and a conclusion template. That's literally everything you need for proportion confidence intervals on the exam. Here's a quick recap. Let me count these on my fingers. 1. The formula, p hat plus or minus z star times the square root of p hat 1 minus p hat over n. Memorize it. 2. Always check all 3 conditions, random, large counts, and the 10% rule. Always show the numbers. 3. Bigger samples mean a tighter interval. Higher confidence level means a wider interval. 4. Say confident, not probability, and always include context in your conclusion. Okay, so the practice worksheet, quiz, and homework are all linked in the description below. Do the work. That's where it actually sticks. I'll see you tomorrow.